In today's note, we're going to be looking at interpreting statistical summaries. So what we're going to be looking at is different representations of data and analyzing or looking at how to analyze these representations. So two terms we want to consider is reliable data and valid data. So they sound like they may be the same thing. However, reliable data focuses on the results of a study being able to be duplicated. So basically your data that you collect or you present is reliable if they can be replicated. Now this doesn't mean that the exact same results are coming up, but the same overall trend is being produced when you do the study over and over again. It is valid data if the results can accurately represent the entire population. And we've talked about this in previous notes. So again, reliable means that you can reproduce the data, and valid means that it accurately represents the population. Again, we've talked about data being represented graphically throughout the course, but again, we can also see it represented in chart form. And as we've seen in a lot of questions, data is usually given to us in charts or tables. Now, graphs give a visually more appealing view of the data, as you can easily see, because the table tends to be not very appealing. Graphs can have some creativity to them. Graphs also allow for an easier comparative conclusion to be drawn with respect to what the trends are between variables or just overall, because again, you can see the data. With raw data, you can represent them in a chart form, because again, you're just presenting what data you collected, so you don't really need to create anything from that. Just representing it in short form is fine, and then you draw the trends or the inferences out when you make the graphs. And again, a changing of the scales of a graph is a technique used to change the magnification of data. So we've seen this before when we've talked about bias, but basically this is referring to a zero scale. So when we have a graph where we can see the zero on the scale, that tends to let us see the overall picture. But if we want to magnify or misrepresent or influence the opinion of something, we may choose to magnify our data. So in example 1, both graphs represent the same data, the closing price for the stocks of company X over an 11-month period of time. Think of a scenario where someone would choose or would use each graph to show the data. So we have two graphs, they both represent the same data. As we can see, this data in the green box is being represented entirely by the second graph. So it's the same data, just again, one is viewed or magnified more. So if I look at the first graph, what conclusions I could get out of this is that this graph shows stable growth. It shows a slow growth because it doesn't seem to be growing that much, while the second one shows rapid or volatile growth, because again, it's fast over a period of time, but it's also up and down. So it shows that it's volatile, which means it's not quite consistent. It could be up, it could be down. It just depends. So I would use the first graph if I wanted to show or be shown to someone who is looking for something that is a secure investment or a medium to low risk investment, because again of that stable and slow growth. Yes, it's growing slow, but there's less risk involved. So someone looking for a secure medium to low risk investment. And then for the second graph, this would be someone who is a high risk investor. I would show them this type of graph because this is a graph that would represent a high risk, high reward type of situation, because it looks like the data is increasing rapidly, but it could also decrease rapidly. It just depends on when you're investing. So it all depends on what type of scenario you want to present, because again, there's nothing wrong with the data. The data is accurate in both. It's just how it's being represented. In example 2, a survey at a local high school asked students if they have read a book in the last year for recreation, and the table shows the data gathered. So we're looking at males and females, whether they read a book or did not read a book. And if we look overall, for males, there's 123, and for females, there are 101 overall. So this data that we have here in the table is our raw data, and this can be represented in various ways. The first one would be a multiple bar graph. So we've seen these before on assignments, but a multiple bar graph, we have different quantities represented by different colors placed side by side. So here we can see that we have our male represented in the first group, and we have the number of books, or the number that have read a book in the first column, and the number that have read a book or not read a book in the second column. So I'm just going to make it a little bit more visible for the read a book ones. So that's a multiple bar graph. A split bar graph is a graph that shows different quantities, again represented by different colors and lengths placed one above the other. So this is taking the two graphs that we've just seen, and instead of placing them side by side, it is placing them on top of each other. So it's just continuing the graph. So you would have to interpret that this lower section here of red is actually 42, and this upper one for the males is 81. And again, for girls, 73, and for boys, or again, for girls, 28. So you would have to interpret that on your own from the data. So that's placing them on top of each other. And finally, we have a relative split bar graph. So this is similar to the last one where we're taking our two set types of values and placing them on top of each other, except now what we're doing is dealing with percents, and they total to 100. Still represented by different colors and lengths, and they're placed one above the other. So here what we're looking at, instead of, rather than the actual values, we're looking at the proportion or the percent of each situation. So again, in red, for reading a book, we can see it is just over 30%. And same thing for girls or females, just over 70%. So we can see the representation out of 100% for each situation. So looking at these three types of graphs, we want to know which of these graphs created best shows, or which of these graphs that were created best shows which gender more frequently reads for pleasure. So if I'm looking at these three representations, the one that I would argue for that shows which gender more frequently reads for pleasure would be the relative split bar graph. And the reason that I would choose the relatively split bar graph is because sample sizes are the same. Well, sorry, the sample sizes are not the same. So between the boys, or the males and the females, we saw earlier how there were 128 or 123 males surveyed and 101 females surveyed. So it's hard to see the representation because there are more boys answering than girls, or more males than females. So when we see the relative split bar graph, we see everything in an equal percentage, right? They're both out of 100%. So we can see then what percentage of each group either read a book or did not read a book, and then make the comparison from that. And then B, draw another conclusion based on the graph. So again, this could be anything from which one or which gender or which group does not read a book more, right? Or some other variation of that. So again, it's something you can look at the graphs and come up with, basically analyze it and see what inferences can we make from this. So again, the two kind of main things we should get out of this is reliable data versus valid data, and the three different types of bar graphs that we could use to represent our data.